Hello everyone, welcome back to my YouTube channel. In the last video, we broke down the most misunderstood concepts in Python, which is instance method, class methods, and static method. We not only learned what they are, and also we learned where to use them. If you haven't watched that video, pause this video right here, check it out, and come back. Because what we are building today builds on top of that. So please check that video out before continuing with this video. Today we are shifting from understanding methods to validating their behavior like real engineers. Because writing code is one thing and proving its reliability, that's what makes real engineers. In this video we are going to build a class called calculator and implement two methods in it, which is add method and divide method. And we're going to look at three different ways how we could test them and see how each method is better than the other. So if you are serious about writing maintainable backend systems, APIs, testing isn't optional. So let's get started. So here I've implemented two methods, add and divide. So add method basically adds both the parameters and gives the result, and divide method also does the same. It divides its parameter and returns the result. But also you can see if the denominator is 0, I've been raising an exception here saying that denominator is not 0. So we are going to test these two methods here. So the first method which we use to test is by manually testing it. So in manual testing method, what we do is we try to invoke the methods with the parameters, arguments, and we see if we get the same as what we expect. So here you can see add method we have invoked with parameters, arguments as 2 and 3, and we expect 5. So what we do here is we try to execute these methods and see if we get what we expect to get. So also there is one more case that I've tried to test with the divide method, which is when I try to pass the denominator as 0, I'll try to see if I get this value error exception. Since divide method throws value error exception if we send denominator as 0, I'm going to test that as well. So here now I'll try to invoke manual testing file. Here you can see I'm manually checking if whatever the result that I've got is same as what I expect. That's why it is called manual testing. So here you can see all of those matched. Here whatever I expect is 5 and also whatever I got is 5. Same goes with the divide method as well. 5.0 is what I expect and what I get 5.0 itself. And also for this case I pass 0 as a denominator and the value error is being thrown. And all my methods are working as my expectations. This is first method of testing. Here we manually verify the output of each method with what we expect. So next comes assert. So here instead of manually verifying the output with the expected output from the manual method, we try to assert the results from each method. As you can see here, I'm just trying to assert if whatever that is written, add method returns is equal to 5. If it is equal to 5, then this assert passes. And if for the divide case also, if you see, I divide 10 by 2 and I should get 5.0. I'm directly asserting, and if this assertion fails, one of the method that we implemented is wrong. That is how we test in assertions. Let me try to test this assert method. Python test assert.py. As you can see, nothing is printed here. Like nothing went wrong, so nothing got printed here. Now if I try to change 5.0 to 6.0 and try to run this, you'll see assertion error. See, as you can see, this 10 by 2, this method gives 5, but what I was expecting is 6.0. So it says assertion errors, meaning the value from the divide method doesn't match with what I am expecting. Here I am asserting, so this verification is known as test by assertion. The same goes with value error. Instead of value error, I'll just type generic error, some key error, some any other error. I'll try to run this now. I'll change this back to 5.0, and now if I try to run this, you can see we got value error. However, whatever we were asserting gave us what we were asserting was key error. So next comes this calculator test method. Here what we do is we implement a class which extends unittest case. In here we are going to implement different methods which are going to check if whatever the response from our methods are same as what we expect. So this is how we test using unittest.testCase class. So when we try to run this file, what it does is it is going to invoke each of these methods and see if whatever we are assert here in this case, if we are checking for the equality, or we are checking if whatever the return results of add is matches with whatever we are expecting, and in this case we are going to check if it raises value error. So let me try to run this test calculator.py. Here you can see it also gave a report saying we ran 3 test cases and everything seems to be okay. So let me try to change this to 6 here, which is not what we expect, and let us see what the report shows us. Okay, so here you can see there is one of the assertion failed, which is this returned 5.0, whereas what we expecting was 6.0. It also ran 3 tests and one of the test case got failed. So this is how this unit test got test case class. This is how we write a unit test case class and verify the reliability of each methods that we implement. These are the 3 methods how we can test the methods that we have implemented. As you can see, manual testing requires us to manually verify whether the results given by the methods matches what we expect, whereas in the assertion method we try to assert whatever the results we have and compare it with the expectation. It automatically compares. We don't have to manually check the console as well as what we expect. Assertion automatically compares it. And when it comes to test calculator, this method where we extend test case class, here it automatically runs all the test cases inside the class and generates a report which shows which test cases failed and which passed. As you can see, each method is better than the other. So the most robust way is to write a test case using test case class, because we might be having multiple test cases throughout our entire code base. It becomes tedious to manually verify or to assert everywhere and check. If we have a report that is generated once we run the test cases, it would be much more convenient for a larger code bases. Alright, so today we didn't just write a calculator class, but also we tested it properly. Now you can clearly see the difference between it seems to work and it's tested and reliable. If you have any doubts whether about assertions or unit test cases, drop your questions in the comments below. I personally read through them and I'd love to clarify anything that's unclear. Also, all this code from this video, including the calculator implementation and the test cases, is available in the GitHub repository. I've attached the link in the description below so you can clone it, run it, break it, modify and really understand how it works. And this is just the beginning. I've got some really exciting tutorial series coming up, especially around AI integrations, automation workflows and practical engineering use cases. If you're serious about leveling up your backend, you don't want to miss what's coming next. So make sure to like this video, subscribe to the channel and turn on that notification bell so you never miss an update. I'll see you in the next one. Thank you.